Eric from Advantech, and together with Frank from 6WIND, we'll walk you through our portal and explain how to use it. Our portal is designed to allow developers to test performance and functionality of their VNFs. We are running on an accelerated OpenStack environment powered by 6WIND software and Advantech hardware. You can access it via the remote evaluation services. It's designed to test drive VNFs and compare performance running in an accelerated 6WIND environment or on a standard OpenStack environment. Details how it all works can be found on the portal, including a frequently asked question area where we collect common questions that we get asked. You can register by clicking on the Register tab. Fill in the form or send an email following the link on this page. After you received your secure login, you can use this to get access to the portal via the Login tab. To secure the OpenStack environment, it is only available for users that are logged in to the portal. After 12 hours of inactivity on the portal, access to the OpenStack environment is removed until you log in to the portal again. Now that you have logged in, you can open the Support tab. Here you can find documentation on how to use the platform and how to use also iPerf to do performance tests on your VNFs. When you are ready to test drive your VNF, go to the Test Drive tab. Here you can find a list of OpenStack services available, and if you have any virtual machines already running with a floating IP, these are accessible from the outside. How to access them you can find in the bottom of this page. Accessing the OpenStack is via the Go button. This will open a new page with the OpenStack dashboard where you need to use the portal credentials to log in. Frank will now talk you through how to use the accelerated environment.
Hello, my name is Frank Jimenez from 6WIND. Welcome to the Advantech Remote Evaluation Service featuring the 6WIND Test Drive portal. The portal is accessible to registered users and provides a test environment called a project for developers to evaluate VNF functionality and performance with 6WIND's Virtual Accelerator. This video provides a summary overview of a project's relevant components as well as a demonstration showing a simple setup and execution. The project runs on Red Hat OpenStack platform populated with 4 compute nodes. While this is a shared resource, projects are mutually exclusive. Developers build and test VNF applications, then compare and confirm 6WIND's Virtual Accelerator performance boost within the confines of the project. I'll proceed with a high-level description of the topology. As I said before, the test environment comprises 4 compute nodes. The first 2 nodes are referred to as accelerated compute nodes because they have 6WIND Virtual Accelerator installed. 2 more nodes are referred to as standard Linux nodes and do not have 6WIND's Virtual Accelerator installed. With the exception of 6WIND Virtual Accelerator installed in the first pair, all nodes are identical. All 4 nodes are connected to an Ethernet switch via 10 gigabit Ethernet links. The base topology is complete. Any new changes are at the user's discretion. Now I can move on to describing the demonstration setup, and then I'll demonstrate 6WIND Virtual Accelerator in action. First, I will create 4 identical VMs. I will use the same image for all 4 VMs. No special images are required to take advantage of 6WIND Virtual Accelerator. I named the VMs on the accelerated compute nodes VM Accelerated 1 and 2. The VMs residing on standard Linux, no 6WIND Virtual Accelerator installed, are named VM Linux 1 and 2. Since this is a shared test environment, a VXLAN tunnel is created to allow communication between the VMs residing on different compute nodes. At this point, we will move on to the actual demonstration. For the demo setup and execution, I use an Ubuntu machine to access my project. All the necessary packages and files are installed, and I have already used my browser to log in to the portal and access my project. I've also opened up a terminal to execute Neutron and Nova commands to create a network and to create identical VMs on each compute node. First, I will create a network called nettest, and then I will create a subnet called subnettest and associate it with nettest. To simplify data entry, I'll store the network ID number in a variable. Now I can use the variable instead of typing out the entire network ID. I'll start creating two VMs, VM Accelerated 1 and 2, and associate them with accelerated compute nodes 1 and 2 that have Virtual Accelerator installed. So I've created my first VM, Accelerated 1, and it's on the Accelerated Compute Node 1. Now I'll create the second Accelerated VM by just going back to the original command and changing a couple of items here. Now I'll create the unaccelerated VMs. I'll just use the same command and I'll come back here and type out different names for the VMs. Of course, they will be on a different compute node. Finally, we do the last VM. We've finished configuring the VMs that we will use for our test. So now we'll go back to the browser and see if we've created those instances. And yes, they're shown here. I'll refresh the screen. And I'll sort them. And you can see all 4 VMs are created, and of course they are all running. For the throughput test, I will use iperf3. This is a simple command line application and will quickly provide a good measure of expected throughput. So I'll come over here at the web browser and I'll right click on each VM and select Open Link in a new tab. Now I'll go to the first tab. Here I'm going to click to show the console, so I'll select console. And then I'll click here on this link to show the console only. Now I'll check the IP address of this VM. I will use the IP address when I configure the second VM in the iperf test. So let's go ahead and run iperf here. Now we'll run it in server mode. We'll go to VM Accelerated 2, and here we'll run iperf in client mode. The throughput test indicates total bandwidth of 8.71 gigabits per second. That's over 80%, close to 90% of a 10 gigabit Ethernet link. Now we'll run the same test on the non-accelerated VM. So we'll go to VM Linux 1, check its IP address, and run iperf in server mode. Now we're on VM Linux 2 and run iperf in client mode. As you can see, a VM's throughput is drastically limited on a host that is not running Virtual Accelerator. In this case, about 36% of a 10 gigabit Ethernet link. Or put in a different way, by adding Virtual Accelerator to the host, a VM's throughput dramatically increases to the point where a 10 gigabit Ethernet link is almost 90% saturated. I invite you to test drive your VNF or VM here at the 6WIND Test Drive portal provided by the Advantech Remote Evaluation Service. Thank you for your time, and this concludes the demonstration.